Hello everyone, and welcome to the first part of a series of data presentations. I first gave these presentations at the third annual HEALTHQUAL All-Country Learning Network in March of 2012 in Kampala, Uganda. And this series of presentations will go through various data concepts which together will help you create or translate raw data into beautiful data reports for decision making. And the presentations are split up into a series of modules. This first module is going to be about data analysis, how to think about data, how to ask the right questions about the data, and how to use the data itself to ask those right questions. So we're going to jump right into it. So this first slide I'm going to be referring to very often throughout these series of data presentations, and I want everyone to think of themselves as a designer. We are constantly designing the systems and processes of communicating the quality of clinical care provided to people living with HIV/AIDS. And as designers, our goal is to strengthen these processes, increasing both efficiency and reliability. So ultimately what we want to do is measure the quality of the care provided to the patients that we care about. And in order to do that, that data has to go through several different processes and transfers before decisions can be ultimately be made that will impact the quality of care provided. First, the care provided has to be documented on a chart somewhere. That chart then has to be selected or sampled. From that chart, the data has to be collected and abstracted. Once the data is collected, it has to be analyzed, visualized, and then reported on a data report. And then from that data report, interpretations will be made about the data, which will ultimately lead to decisions made. And these series of data presentations will go through what I've highlighted in red here. How to analyze or think about the data, how to visualize the data, how to put that into a report, and how to interpret the data. So I want you to think of yourself throughout this whole presentation as a designer. How can we improve each of these processes so that we know exactly what's going on at the clinic level? How is the care being provided? So part one of this series of presentations is about data analysis. How can we translate raw data into meaningful information? And here are just some various topics throughout the presentation. We're going to talk mostly today about exploratory data analysis and kind of the pitfalls and usefulness of aggregating or grouping the data. We'll touch very briefly on data quality, inferential statistics, confirmatory data analysis, and descriptive statistics. Right now there will be another module that kind of goes over the more technical details about descriptive statistics. And perhaps in the future we will create more modules for each of these other topics like data quality, inferential statistics, and confirmatory data analysis. So let's jump right into it. So before you do anything with the data, you need to make sure the data are of good quality. Before you analyze the data, you need to make sure the data is valid, there aren't any missing values, did all of your clinics sample correctly, was your sample actually representative of the population that you're interested in. You want to make sure the clinic staff adhere to sampling methodologies, and if there are any issues with the quality, you just want to make sure that you note that in your analysis to make sure that when decisions are being made that these issues of quality are upfront. And here are just three different ways you can check your data in Excel, for instance. Count and blank lets you count the number of blank cells to check for missing values perhaps. Count data range allows you to count how many cells contain numerical values. And you can even use a count if and add a condition so that it only counts a number of cells that meet that condition. These are just three various ways you can quickly check for data quality using Excel, but there are various other ways of doing that. and various other packages and software tools that will also allow you to check for data quality. But we're not going to talk too much about data quality in this presentation. We're going to talk more about how the second step, how we can use the data to ask the right questions and explore what we're interested about. So statistical inference, just very briefly again, it allows us to make inferences about the population that we're interested in. So our sampling methodology ensures that our sample is representative of the population, and statistical inference underlies kind of the ability for us to do that. So that's all I'm going to talk about here. We may talk about this more in another module. So exploratory data analysis. This is kind of what we're going to be talking about for the rest of the presentation, and kind of some ways that you should think about the data as well. So exploratory data analysis was an approach pioneered by John Tukey. He was an American statistician, and the approach summarized raw data sets into easily understood formats, often visual graphs. And the technique really used graphics to reveal the data. And this is a really great quote, I think, by John Tukey that really tells you the power of exploratory data analysis. Far better an approximate answer to the right question, which is often vague, than an exact answer to the wrong question, which can always be made precise. So the questions are really important, and I think using exploratory data analysis, we can use the data itself to generate those questions rather than have assumptions and try to ask the questions without looking at the data. And but how do we use the data to ask the right questions? Well, here's a really cool example. So here are 4 data sets, each with similar characteristics shown below. Each of these 4 different data sets has the same number of x and y values. The mean of all of the x's is 9 for all of the data sets. The mean of the y's is 7.5 for all the data sets. And the best fit line, or the equation of the regression line, is actually the same for all of these data sets. So just looking at these 4 data sets, they're raw data, it's really kind of hard to visualize what's going on in your mind. But however, when you graph them, it really reveals what's actually going on. Just by looking at the data in the previous slide, you really didn't have an idea of what the data actually looked like or what the data were actually saying. So this graphically representing the data sets tells you a lot more than just the few statistics that they shared. It tells you a lot more than just by looking at the raw data itself. So descriptive statistics is another powerful tool that we can use to make sense of our raw data. And often it's used in combination with graphics to generate the questions, to generate the ideas. And it's just a straightforward presentation or a summary of data, and it's a way to understand and compare data sets. And often descriptive statistics are broken down into 2 various groups. One is the central tendency, or what is the most likely value, and you could think of that as a mean, a median, or a percentile. So a mean would just be an average of a data set. A median would be the value of the data set where 50% of or half of the values fall below that and half of the values fall above that number. And a percentile is very similar to a median. For example, a 25th percentile would mean that 25% of the values fall below that number and 75% of the values fall above that number. Another descriptive statistic describes kind of the variation about that central tendency. So when you think how different are various pieces of the data from each other, how far apart are they from each other, and you can think of that as these are just 2 different ways to describe that: the standard deviation and the interquartile range. And we're not going to go too much into each of these descriptive statistics in this presentation, but we have another module that will go over them in more detail. And finally, we have the min and the max, which are just like they sound. It's the minimum and maximum value of a data set. And it kind of just gives you a range of the data set. Where do the data lie? So I just want to bring us back and think about this flow diagram again. The purpose of using statistics, the purpose of using graphs is to help us make better decisions under uncertainty. It's hard to know exactly how the care is being provided, the quality of the care being provided, and we need to do the best job as possible to make sure that the decisions that we're making are impacting the care provided positively. So it's really important to always keep in front of your mind when you're doing analysis, when you're visualizing the data, what decisions will be made as a result of this analysis, and two, how will this analysis influence these decisions? So here are two different ways you can analyze data. Cross-sectional, which analyzes different units at the same point in time. For example, comparing individual clinic scores for a particular round. So here in the red box, I'm comparing round 1 scores for across all of these clinics. So if I were doing that, I'd be doing a cross-sectional analysis. Longitudinal analysis analyzes the same units over a period of time. For example, comparing an individual clinic score across 3 rounds to see how the clinic is performing over time. And we can do a longitudinal analysis for one clinic, we can do it for a group of clinics, as long as that cohort or that group of clinics remains the same over time. And what this allows us to do is to see kind of trending analysis. It allows us to make comparisons from previous to future rounds and if a clinic or a group of clinics is improving over time. So the rest of the presentation really talks a lot about aggregation. It's both its usefulness and its pitfalls. So aggregating data is useful because it allows us to easily compare large data sets, both cross-sectionally and longitudinally. However, when you aggregate the data, it can affect how you interpret the data. The more elements that are aggregated, the harder it will be to see variation among those elements. And really, variation is what makes data intriguing. If I were to look at the aggregate score for 15 clinics, it's very hard to say how an individual clinic is doing. So there's a sacrifice. There's kind of a balance being played. But if we only look at individual clinic scores, sometimes it's hard to make generalizations. It's hard to compare large data sets. So we have to find a good balance. And there are various data aggregation points. At the patient level, each patient is a data point. Looking at that data, we can say how was an individual's care, how was the quality of an individual's care, how was the quality of an individual's care. And at the clinic level, patient data are aggregated. This tells us how the clinic is performing. And at the national level or a level higher, a regional level, clinic data are being aggregated, and it tells us how the nation's performing or how the region is performing. So here's just a really cool effect called the Simpson's paradox effect, and it really shows you how aggregating the data can affect your interpretation of the data. And this effect describes is when a correlation present in 2 groups is reversed when those groups are combined. And it occurs when frequency data are hastily given causal relations. So here's just a really cool example from 1991. It compares Alaska Airlines to America West Airlines, and it's the number of on-time arrivals at various airports for these 2 different airlines. If we look at the aggregate, if we look at the 5 airports together, we'll see that we can say maybe that America West Airlines performs better on average than Alaska Airlines. 89% of their flights are on time versus 86.7% of Alaska Airlines. However, when you look at the individual airports over time, you'll see that you know, Alaska Airlines actually outperforms America West Airlines at every airline, at every destination. If you compare LA, Alaska Airlines is 88.9% on time versus 85.6%. Phoenix 94.8% versus 92.1%. San Diego 91.4% versus 85.5%. So, etc. And why is this happening? How can America West Airlines perform better if we look at the aggregate, but Alaska Airlines is better if we look at each individual destination? Well, if you look more closely, what's actually happening is that America West Airlines, most of their flights fly into Phoenix, and Phoenix is a very temperate city. It has very temperate weather, and 92.1% of their flights there are on time. However, Alaska Airlines, most of their flights are into Seattle, and it rains a lot in Seattle, and only 85.8% of those are on time. And so although Alaska Airlines performs better on each of the destinations, because America West Airlines flies mostly into Phoenix and Alaska Airlines flies mostly into Seattle, when we aggregate that data, it appears that America West Airlines is a higher performing airline. And so this really changes how we interpret the data if we look at the individual pieces versus the aggregate. Here's another really great example of how aggregating the data can really affect the interpretations you make about the data. So during the cholera epidemic in London in 1854, John Snow's investigation of the data led him to conclude that a certain water pump on Broad Street was responsible for the outbreak. And John Snow is credited kind of for the birth of modern day epidemiology. And he's also credited for stopping or preventing the cholera outbreak. And if you look at each of these graphs, so let's start with the first one. It shows the deaths from cholera each day during the epidemic. And you can see that right here is when the Broad Street pump was removed. So, when it was removed, it kept going down. The deaths from cholera kept going down. However, it was already, trending down already. Does this really tell us if removing the pump had an effect on stopping the epidemic? It looks like it was already on its way down. But let's look at this graph now. So here is also the deaths from cholera on the y-axis. And instead of looking at by day, we look at it by week, our 7-day intervals. And here, the handle was removed right here. The Broad Street pump handle was removed here. And wow, as soon as the handle was removed, the number of deaths drastically decreased. This is telling us a different story than if we look at it by day. And finally, if we look at this final graph down here, you'll see that, wow, the epidemic was actually growing before the handle was removed. So each of these, and this was only by shifting the 7-day intervals 2 days forward. Instead of looking at September 1st through 7th, we're looking at September 3rd through 9th now. So how you analyze and aggregate the data really has an effect on how you interpret that data. It tells you a different story. And for more about this example, I really recommend Edward Tufte's Visual and Statistical Thinking, Displays of Evidence for Making Decisions. And this is where I pulled this graphic from. So I really recommend that resource, and it goes into more detail about kind of the effects of aggregating and how that can affect the interpretations that you make. So now let's bring it back to real world examples that we may be encountering in our clinics and as we manage clinics. So at the clinic level, when analyzing data, just some questions to keep in mind are, who will be using the data to make decisions? Will it be medical care providers, administration staff, etc.? How will your analysis affect those decisions? Always think about that. Always think forward. What data are being aggregated? Is it So here in this case, it's patient indicator data. And what ways can we sort the data? We may be able to sort by demographic information, age, sex, date of birth, risk factor, ART status, and what historical data do we have already? Are there data from previous rounds that we can take advantage of to make more sense of the current round of data? So here is just a quick clinic level example. Here's just some raw data for a clinical visits indicator. And just by looking at this data, it's pretty hard to make sense of it, but if we aggregate that, we'll find out that the rate of clinical visits is 50%. 28 out of the 56 people satisfied the criteria for this indicator. So, what decisions would you make if I told you that the overall clinical rate of clinical visits was 50%? And then what would you do if I told you that those patients on ART had a rate of 59% and those not on ART had a rate of 17%? What would you do if I told you that females had a rate of 71% and males had a rate of 29%? If we only looked at the aggregate, which was 50%, and we didn't stratify and look at the data in various other directions, such as ART status or sex, we may be missing a very important piece of what the data are telling us, and really it would affect, I think, our decision making. We want to make the best decisions possible. So although looking at ART status or sex may not be we may not be able to infer directly from this data that ART status and sex has a role in determining clinical visit success. However, these data are very suggestive, and perhaps you would do a more rigorous study afterwards. So here's an example of where the data are telling you an interesting story, and by looking at the data, we can ask the right questions and pursue those questions with more rigorous studies to hopefully elucidate what's actually going on in our clinics. So here's a national level example now. And let's just go through the same questions as we did at the clinic level. So when analyzing data at the national level, some questions to keep in mind are, who will be using the data to make decisions? Policymakers, stakeholders, donors. For example, how will your analysis affect those decisions? What data are being aggregated here? Clinic level data. And what ways can we sort the data? And just like at the clinic level, we may be able to sort by demographic information of the clinic in this instance, not the patient, but the clinic. The type of clinic, the number of patients at the clinic, the region or province or department or district the clinic is in, the wave of implementation. Again, what historical data do we have already? Do we have previous rounds of data that we can make use of to provide us with more context? And what type of statistics are we using to describe the data? Are we looking at means, medians, percentiles? What can we do? So here's an example. Here's a data set that you may have saw a little earlier. If we look at the total mean of each of these clinics by round, we'll see that these clinics have steadily improved from 24 in round 1 to 34 in round 2 to 45 in round 3. If we look only at the north region, we'll see that they have improved from 3 to 25 to 46. However, if you look at the south, you'll see that they have kind of stayed the same throughout these 3 rounds, 45, 43, 44. So if we aggregated all of these clinics and only reported those results and we didn't break it down by region, we wouldn't see that the average score has only improved in the north and not in the south. So that may have an effect on the decisions that we make ultimately as donors or as people at the national level making decisions about how to allocate resources or technical assistance to various regions. So I just want to talk a little bit more about this example. In the previous slide, we showed you the mean of each of these regions over time across 3 rounds. But was the mean score the best way to describe that data set? We could have looked at other statistical tools such as medians, IQRs, which we may learn about later, standard deviations, percentiles, outliers. Was separating the clinics by district or region the only way we could aggregate our data? If we had other clinical descriptors available, such as type of clinic, perhaps stratifying by those descriptors may have also been illuminating. And what if the number of clinics changed from round to round? What would we be able to say about the aggregate results? Well, for national benchmarking, it may be important to aggregate all of the clinics, regardless of how many clinics there were from round to round. However, for a longitudinal analysis where we're comparing a group of the same clinics over time, it may be important to only look at those clinics that reported on each of those rounds. So descriptive statistics is a way we can summarize data and aggregate data to make it more comparable, but it also hides variation in the data. We can't say much about an individual piece of the aggregate. We really don't want to just look at averages of clinic indicator scores, but we don't want to just look at raw data either. And finding the right balance can be challenging. And here's a really cheesy quote by Daniel B. Wright, who I don't know, but I think it's a funny quote, but I think it makes a lot of sense. Conducting data analysis is like drinking a fine wine. It is important to swirl and sniff the wine, to unpack the complex bouquet, and to appreciate the experience. Gulping the wine doesn't work. So I think really, it's hard. Doing analysis is hard, but I think the longer by appreciating the process and by taking the time to find the right balance is very important. We want to find the right balance between the ability to compare, to summarize, to see patterns and trends, and being able to see the interesting variation and granularity of the data. So here I think is a really great example of how we can balance both variation and the ability to compare various data sets. So here's an example from Namibia. This is their food security indicator. And this is a box and whisker plot. And the box and whisker plot is great because it can describe 5 different descriptive statistics at the same time. So here at the end of the tail, we have the minimum value of the data set. At the start of the box of the white end right here, at the start of the box, we have the lower quartile, which is also the 25th percentile. So 25% of the scores fall below that value and 75% of the scores fall above that value. The middle of the box that separates the white and the black is the median, so 50% of the values fall below, 50% of the values fall above. At the end of the box is the upper quartile, or the 75th percentile, and 25% of the scores fall above that value, and 75% of scores fall below that value. And at the very end here, at the end of the whisker on this side, is the maximum value of the data set. So this tells you a lot about one particular data set. It tells you 5 different things. It also tells you kind of the variation between the scores. The wider the box, the more variation there is amongst the numbers, the rates of that data set. And the great thing about a box and whisker plot is you can compare each of these values very easily just by looking up and down these various data sets, these various box and whiskers. So I can easily compare the minimums of each of these data sets, easily compare the lower quartile, easily compare the median, and easily compare the upper quartile and the maximum value. So I can see over time if this indicator is improving in 5 different ways. And it's very easy to see, I think, just from looking at this, that the food security indicator has steadily improved across these 6 rounds of data. The median value, for instance, has increased over time. So another great way, I think, to balance these various things is to include all of these values in a table. And here I this is an example from a data report that I created, and it shows you the number of clinics, the number of eligible patients, the mean, the median, the 25th percentile, the 75th percentile, the min, and the max for this particular review period. And this funny little graph right here is actually called a spark line, which was an invention by Edward Tufte, and we'll be just talking about them a little more in the data visualization module. But just really quickly, what the spark line tells you is each of these individual ticks is an individual clinic score, and this red tick is the mean of those scores. So very quickly I can see kind of the variation amongst scores and the mean at the same time and compare that across the various review periods over time to see if my indicator is improving. So just by looking at this, I can see that this indicator has improved over time just by looking at the red mean. So lastly, this type of graph is called a heat map, and I think it's a really great way to look not only at individual clinics' performances over time, but also just kind of the general overall trends of all the clinics. I can say very easily that in round one there were more red squares than there were in the most recent round. And what do these colors mean? Well, here's the legend. So the more red the square is, the lower the rate of that indicator. The more green, the better the rate. So really quickly over time, we can see that if the clinic's boxes are getting more green over time, we know that the clinic is improving over time. And I can see that very quickly, like Clinic H seems to be improving very well over time, and Clinic P seems to be improving well over time. And I can also see very quickly, oh, Clinic F may need some more technical assistance. It's been over six review periods, they haven't been able to improve the food indicator result. So this is just, I think, a really great way to look at all the clinics at the same time, but still have an idea of aggregate level patterns and trends. So that's the end of the first module, and I hope you enjoyed it. If you have any questions, comments, or suggestions, please email me. Before June 22nd, you can reach me at this email, alw10@health.state.ny.us. After June 22nd, please email me at awei711@gmail.com. Thank you very much for listening. Our next part of the series of presentations will go over data visualization. So see you when you go through that presentation again. Thanks a lot.